Okay, great. Welcome, everybody. Thank you so much for taking the time to join us today. My name is Carolyn King, and I'm the head of growth here at StreamNative. Very excited today to be hosting Jesse Anderson from Big Data Institute. Today, Jesse is going to be talking to us about managing real-time data teams and the different challenges that come with that. So with that intro, I will go ahead and hand it off to you, Jesse.
Thank you, Carolyn. Thank you, everybody, for being here for this webinar. Once again, this webinar is called Managing Real-Time Data Teams. In this webinar, I'm going to go through and talk about some of the issues that happen when you either move from a batch team into real-time or going from a small data team to doing real-time big data. So let's talk about some of those management issues. And with that, here is our itinerary. We're going to talk about the real-time effect on data teams, what that means for the data teams. And that has two specific manifestations, in my opinion. One of those manifestations is on the operations side. So on the operations, we will have to deal with the real-time side of that. The other part is that we have to deal with data engineering issues. We will have to make sure that our teams are set up correctly. And finally, we'll have to talk about what should we do about this. Now that we know about the effects, what operational, what organizational changes do we need to make? So to start off with, we need to think about how we deal with technology changes, especially with real time. So you should know as a manager that the move to real time affects your data teams directly. And it isn't just a technology choice. For example, many managers that I've talked to or dealt with think that it's just adding in a real-time technology. It's just let me just add Pulsar into the stack. Let me just add Kafka into the stack. And it's just one more technology that we're dealing with. Well, the issue is that really isn't the case. When we start to add these new technology choices, these new technologies, we have to be ready organizationally for that. The reason we have to be organizationally ready is because the complexity levels are going to increase dramatically. If you've ever read my writing before, you may know that I hypothesize that big data is 10 times more complex than small data at batch. So 10 times complexity. So if you have a small data team that's just going into big data, that's a dramatic complexity increase. And I also hypothesize that on top of batch big data, that real-time big data is another 5x complexity increase. So we have some substantial complexity increases, and management needs to know about this because no longer, it's not just a technology choice. Some companies are saying that this is easy, that you just kind of fall into it. And no, it's the real world data. My real world experience is showing, hey, this is more difficult. We need to be ready for this. So to that end, management needs to ask, is the team ready? This needs to be a very honest look at the team. We need to honestly say, is our team ready for that complexity increase? And what we may need to do is we may need to actually take a step back and say, okay, the team actually needs extensive preparation before we start this real-time data project. We would look at our team and say, do the data engineers on the team, have they ever done real-time before? Have they ever used a real-time technology? Well, maybe not. You as the manager, you as the team lead need to look at that and say, okay, are we even ready? What do we need before we do this? And this preparation may entail several different things. It could entail that the team just needs some help on training. They may need to be trained on the technologies. And that means that the team is ready. They just don't have the knowledge around that. That's a possibility. You may need even more help. You may need actual direct consulting on this. That could either be consulting in an architecture review to make sure that the technologies are set up in the right way, that you're thinking about the problem the right way, all the way to consulting where there's a consulting company that comes in and implements this for you. Or you could need even more, and that may be around some mentoring, where the mentoring will help you on all parts of this, that you need help with the team side, and help with this and help with that. And that mentoring really goes through the gamut, through the entire range of issues that you have. And for you as managers who are thinking, well, what does this really mean? If we're not ready, or we're just a little bit ready, what does this mean? It means that if you aren't ready, your team is going to stagnate. And that stagnation happens where the team wasn't really ready for what they were ready to do. And they're not going to be able to get to that level. They're constantly going to be behind the 8 ball, trying to get to that level, trying to be able to do this. And that stagnation manifests as, we originally thought this was going to take 6 months. Now we're 6 months in and we're still at just the starting points. That's what stagnation looks like. That's how projects get canceled, because the team wasn't ready for this. So now let's talk about some of the operations issues that we might have. Now, as I talk about data teams, there are 3 different data teams. There are the data science team, the data engineering, and operations team. But it's important that we realize the importance of operations as we start dealing with real-time, the move to real-time. And this is because when we don't have an operations team, or we don't have a well-qualified operations team, that means that we can't deliver that real-time operational excellence. I have seen this personally with either interactions, talking to people, or even with clients. And this lack of realization that we need operations means that we don't have great operational excellence around the uptime, the making sure that the entire system runs well. So it actually is a crucial part to the data teams. Now let's talk about some of the manifestations that actually happen within the business. So one of those important parts is the real-time SLA, that service level agreement. That means how long can something be down, be non-operational, before we say, hey, this is a big problem. Or the team actually says, we will only have a downtime of 1 hour. We'll only have a downtime or we'll go for 5 nines, something like that. Now, it's important for managers to know about the difference in SLAs between a batch and a real-time SLA. So for batch, we often have operations teams that have an SLA for batch in terms of hours, perhaps days. And this is actually an important distinction, that if a operations team can barely maintain those SLAs that are pretty lax, pretty nice or easily done, if they can't hit those SLAs of hours and days, they certainly won't be able to handle the real-time SLAs of minutes and hours. So that once again, the SLAs for real-time systems should be minutes to hours. And why minutes to hours? This is actually a metric that I look for when I mentor a team, of asking them, how painful would it be for your real-time system to be down? And if they say, oh, it can be down for a few days, maybe they don't actually have a real-time problem, or they don't really understand what they need to do operationally for real-time. This is an issue I've seen before. Instead, the answer should be something like, it would be so incredibly painful for any of our real-time systems to be down, because we're depending on it consistently for business. The business needs to know this. We're running our analytics off this. We're doing this, we're doing that. It's business critical. So coming back, and if we don't have an operations team that is at that level, that they can barely maintain a batch SLA, certainly won't be able to maintain a real-time SLA. And so we as managers need to look at that and say, is the operations team ready? Or maybe there isn't even an operations team sometimes. We need to realize, hey, we need an operations team that can not only do operations for batch, but also those real-time levels. But here is the key there. Sometimes as we think, and maybe as technical managers, maybe as technical people, we think, hey, this downtime, there's a technical reason for that downtime. and it's okay and it's acceptable, and this just happens. And in reality, it does. There's the inevitable downtime. But let's talk about what happens to the business. And I think that's the critical metric here of what happens to the business when we don't have that operational excellence. And this means that if we have an ineffective operations team, we don't actually keep our SLAs in place. This means that the business can't really rely on things for our mission critical business cases. I've seen this firsthand. I'll talk to the business side and I'll say, and they'll be talking about the operational problems, and they will say, okay, we just stopped even depending on it. We don't even know if it's up and running. We just don't even use it because it was always going up and down. That is exactly what the business says. The business has lost all faith in the teams and the operations team's ability to keep that up and running. And as a direct result, all of this investment, all of this effort, all of this money that we're putting into a data team, data science team, operations team, it's all wasted because the business isn't using it. And the business isn't using it because they can't rely on it. This is a major problem. This is how, once again, how projects get canceled, projects don't go anywhere. It's because the business can't rely on it. And the business can't rely on it because there's a lack of operational excellence. And there's a lack of operational excellence because we may have the wrong operations people, or we may not even have an operations team. This is critical for businesses, for managers to know. So now let's talk about some of the data engineering issues. And it's critical that managers understand the data engineering implications of going to real time. So here, when we look at the triangle once more of data science, operations, and data engineering, what happens? Well, now we have data engineering gone. It's missing. So that means that data science, that the tasks, the things that data engineering does don't go away. They're still there. Operations is still there, data science is still there, the need for data engineering is still there, but the right people to do that data engineering is gone. This generally means that the data engineers, that those data engineering duties fall over to the data science side. And oftentimes, with all due respect to data scientists, they're not good at this. This is a domain of distributed systems and programming. And the data scientists who don't have this intense software engineering background don't have this. So it's not an issue of that maybe data scientists, if they were put enough effort into this, to learning this, but it's years, it's many years, and sometimes decades to learn data engineering well, to learn these distributed systems well. And oftentimes data scientists have an experience in terms of months, where they've taken a class or two in programming. A class or two in programming does not set you up for success on data engineering sides of things. So that means that data science will often try to make guesses on architecture, and they will make these guesses based on what's popular. So when they go and look and say, what technology should we use? Instead of choosing the right technology, the right tool for the job, what they will do is they will go around and look, okay, this technology is the most popular, I'm going to use that. And the worst part is that they're going to use that technology for everything. And I've seen this firsthand. I've seen this firsthand where companies or data scientists will just focus on that single technology. In that case, it was Spark. They would just focus on everything with Spark. Every technology, every solution, every problem use Spark. Well, Spark is very good for certain problems, but it's not applicable. It's not a great choice for every problem. And that was the issue that the data scientist had in that case. They didn't understand the trade-offs. They didn't understand the difference that a data engineer would. So we want to make sure that we have our data engineers, and this is a common problem, a common missing team, is that the data scientists are trying to do everything data engineering wise, and they're making some problems. And these problems aren't just here, we can patch this up easily and quickly later. What often happens is that the data science team is creating some significant amount of technical debt, and I've experienced this personally. That amount of technical debt actually translates into years of fixes rather than a few hours, a few months of fixes. It is significant amounts of time to clear up data science technical debt. So really what we need to do is, as managers, is make sure that when we start a team, when we start these projects, we have all three teams. Or if we don't have all three teams right now, we need to go back and get our data engineering team in place. As we're looking at our existing data engineers, we need to look and see what level that our data engineers at. If we do actually have a data engineering team, what ability will that data engineering team actually have? Can they barely get by with batch? This is something I've seen. So sometimes there'll be a co-opted team. There'll be a data engineering team, but they'll have been co-opted from other teams, usually a data warehouse team or a DBA team. And they'll have been taken from this and said, okay, you're all data engineers now. And this is an issue because some of those teams, some of those DBAs, they can get by enough with SQL, but they can't get by 100% with SQL. And so they can do enough backflips and batch to get it working. But once we go to real time, it just blows up. So we have to make sure that the team skills are able to expand out to be able to handle real time. So in the chat, if this is something that you're experiencing, let me know so that I can expand more on that, or feel free to ask a question there. So here we have data products. Another thing that you should know is, as if you're on the software side especially, or management side, that there's a big difference between exposing a data product in real time versus either as a REST call or in batch. What that means is when we are using a batch system, let's say Spark or let's say Hadoop, we expose that data as here's a file or here's a directory and all the data is there. And what we can do is we can actually go back after the fact and we can go through and reprocess that file if there's a problem or something like that. Or if we're exposing a REST API, we can move from one version to another. So we could say, okay, we have version 1. Okay, everybody now move to version 2, but we've got version 1 there for the next month or two. You can go back to that. This isn't how data products work in real time. So what we have to do is we can't think of it just as an API or a REST call anymore. We need to make sure that our data products have a schema to them. And if we don't have the schema at all or right, this is going to be the absolute most terrible, most difficult thing for the data teams. And this is because it will inhibit adoption from the other teams, but worse, it's going to either make updates to that data set impossible or difficult, as well as make the downstream updates difficult or impossible. So it's incredibly important that as we start to do real time, that we do have a consistent schema that we're using so that we can expose that data set. So when we expose a data product, we have to expose that data product in Pulsar. We have that data product that says, here is a topic, and that topic has a schema, and this is that schema. One of the things that I like about Pulsar, to kind of give you a background on Pulsar versus Kafka, Pulsar actually has schema built in. Schema is a first-class citizen in Pulsar, and this is the way it should be, quite frankly. And every time you do something in Pulsar, you have to say, this is a string, this is an Avro object, for example. Now with Kafka, all of that's layered on. It's layered on the top. And then you have different schema registries and different ways of sending Avro with Kafka. They're not all compatible. So it's not as good of a story as you'd want there. So that was one of the things personally that I really like about Pulsar. Schema is a first-class citizen because they realize that real-time data products have to have a schema. If anybody has any questions on that, I can go through that. But suffice it to say, a lot of times companies will think that XML, JSON, those are okay schemas, but definitely it's binary. It's Avro that you want to be at, and that's supported out of the box with Pulsar. Then we get into our connections. So what we need to do is we need to make sure our data engineering has high bandwidth connections to the rest of the organization. And we need to make sure that they have that so that there is adequate adoption of their data products, where we could be producing the absolute best, most incredible data products ever. But if the data engineering team is not connected to the rest of the organization, we aren't going to be able to do this. So we need to make sure that we have our data products there, our data products ready, and and especially as we look through this, especially as we start to see our adoption, we need to make sure that we have a high bandwidth connection with our data science team. So there is somebody who chatted earlier about Eugenio. So Eugenio was saying how he doesn't have enough connection as a data scientist, or perhaps he's in business intelligence, to the data engineers. So this can mean several different things. It can mean that management hasn't taken the effort to say it is important for data science to have a good connection or a high bandwidth connection with data engineering. So there's that friction there between the two. As managers, what we need to be doing is we need to be making sure those connections are high bandwidth, low friction, so that we are getting things done for our data scientists. But this, more than likely, Eugenio's problem is actually on the right ratios. And if I were to guess that that your engineering ratios are your data engineering ratios are out of whack. And this means that management is saying, let's have tons of data scientists and few data engineers. So what's happened consistently is when people started talking about let's do data science, let's do machine learning, they said, go hire a ton of data scientists. And that was the message, data scientists, data scientists. So companies will have 20, 30 person teams and either no data engineers or 1 or 2 data engineers. And the issue there is that the ratio is actually opposite what it should be. And this means that when we look at the amount of work that needs to be done for data projects, for data science, machine learning, the actual amount of machine learning effort or time spent is much smaller compared to the rest of the data engineering effort. And the rest of the data engineering effort is making sure we have the right technologies in place, making sure that we have the right data products in place, making sure that data gets from here to there efficiently and at scale. The actual machine learning, it's not to trivialize the machine learning, that's the cherry on top. That's the whole business reason we're going through all this effort. But the issue is that if the amount of effort, the amount of time is significantly more for data engineering. So what often happens in these companies is that they're having a lot of data scientists, 30 data scientists, and all of those 30 data scientists are trying to do something that they're not very good at. With all apologies to data scientists, they're just not very good at the data engineering side. And the reason why they're not good at data engineering is it takes years and years and years of study and effort to get good at the programming side, to get good at the architecture. So coming out with, let's say, 1 class or 2 classes as a data scientist on programming, that just isn't enough. So what will happen is we have 30 data scientists all trying to do something that the reality, a smaller team, a much smaller team of data engineers could do more efficiently. In some cases, I've seen companies with 30 people that they could have actually taken their ratio down to 10 data scientists and 10 data engineers and been vastly, vastly more productive. If this is what you're seeing in your company, let me know in the chat and we can talk more about that. One other thing I want to make really clear is you may be thinking, well, we don't have the right ratio, but that isn't a problem. What actually happens, and once again, I've seen this firsthand, is that the ratios, these incorrect ratios, lead to technical debt created by the data scientists. And you may be thinking, well, technical debt is just inevitable. And to some degree it is. Now the issue here is, how long does it take to pay down technical debt created by the data scientists? In some cases, and I've experienced these cases firsthand, it can take years. It can take a significant amount of time to undo the issues that the data scientists, the incorrect decisions, the incorrect engineering that the data scientists make. So it's significantly better to do this right the first time rather than have to go back through and redo it. Redoing it is very difficult. Once again, seeing that firsthand. Okay, let's talk about what we should be doing. As managers, what we should be thinking about is, we're not a team looking for a problem to solve. This is a recipe for failure, where we say, I'm just going to start doing real time. I'm going to use Pulsar. And we're thinking of it in terms of a technical thing. Putting this technology in place will inherently make us better. Well, probably not. What we need to do is, we need to actually have a specific business problem that we need to solve in real time. There needs to be something specific that we as data engineers, we as managers are saying, the business comes to us and asks us to do X. Well, as they ask us to do X, we say we can't do that. We can only do that in batch. So they say, I want a dashboard updating in every minute. And we say we can't do that. We could do a dashboard that updates every hour, every 2 hours. That's an example of a real-time problem with a business problem, that there's a specific business need that we need to update that dashboard at scale in real time every minute. So with these sorts of thoughts in mind, we need to make sure that we're solving these problems in real time, that we have this requirement of real time, that we have this business requirement. And if we just put technologies in place, sometimes that's necessary, but we always want to make sure, especially as managers, that we have our real-time needs there. One other issue I see consistently, especially at large organizations, is that data teams are forever being compared to their either less technical fields or non-technical fields, usually less technical fields. How many of you had this problem of your team, let's say you're the manager of data engineering, your manager, your CTO will always ask you, why does it take you so much longer to do something? Look at the web development team. Look at the front-end engineers. They can just whip things out like this. And you take so long, you always need a month, you need 2 months. What's the deal there? And this is something I've seen it firsthand, tried to work with those managers and help them understand, oh, actually, the level of complexity difference between doing web programming is vastly different than doing distributed systems and real time. Significant differences. So what it comes to you as managers, what you want to do is you want to make sure that you communicate the value you're providing. You want to say, here is what I'm doing that is so difficult. You want to communicate that complexity, but here is the value that that complexity has. And you're basically going to have to educate. You're going to have to take an educational position to show that. If you want help doing that, I've written several different posts. One is called On Complexity and Big Data. If you want to read that and send that around, it's written for management to say, hey managers, CTO, this is why this is different. This is why this is so much more complex. And that will help you communicate up the chain what is happening. If that's something that's happening to you, let me know in the chat so that I can see that. One other thing I want to really reiterate is that management is responsible for the early success and failure of real-time data teams. What this means is, if we're starting out with real-time, what we need to do is it's up to the managers, it's up to management to make sure that the team is ready for that. It's not as much of a technical issue. There are technical issues that come out of that, but it's up to the management to sort those out. It's up to management to say, hey, this is actually difficult and we need to get training for the team, for example. Or this is difficult and the team just is not ready for this. We're going to have to get some kind of help. That help could be consulting. That help could be mentoring. That help could be this or that. It's up to the management to look at the initial state of their team and say, and make an honest look, take that honest look and say, are we ready? And if the management doesn't take that initial look, then it's, in my opinion, it's the management's fault. So that early success or failure, it's right there on the management. Later success, later stage, definitely on the individual contributors, definitely on the data engineering team, operations team, data science. But early on, it's the management that sets it up. So you heard me refer to some of the posts I've been seeing. So I look on Reddit all the time. I read lots of other posts on other sites, LinkedIn, that sort of thing. And what I see consistently is management setting up the team for failure because they're forcing the team to do something that's incredibly difficult without any help. I'll see posts that are saying, management wants us to do large scale real-time processing and I'm a DBA, I don't have any programming, how do I do this? If your team is starting out like that, that is a recipe for failure. It makes me sad because I've talked about this pretty extensively. I've shared this pretty extensively with many people, but we absolutely have to make sure that we are setting our people up for success. Other parts of that success, having enough people, having people with the right skills, lots of different parts to this. If this is something that's happening to you or to your organization, please feel free to reach out in the chat. So the leading up to this, what we have is I have a new book coming out. It's called Data Teams. It's going to be out in September, in early September. The website there is datateams.io. You can go there and you can sign up so that you can receive a notification once Data Teams is actually out. At this point, once again, it isn't out, but you'll get an email when it is by signing up there. The other thing, if I could get you all to do this for me, I'd really appreciate it. I'm doing a survey, and this is the minified URL to it, tiny.bdi.io/data team survey. And what I'm trying to do in that survey is correlate value created with data teams and the correct usage of those data teams. It's kind of a threefold thing. And I would really, really appreciate it if you all were to fill out that survey. In that survey, as you fill that out, I'll actually send out the aggregated results to you so that you can take a look and show perhaps it's other managers within your team or within your organization saying, hey, this isn't possible to do. Well, what we can show is with the data, the highest level of value is always shown to be once we have all three teams correctly staffed, correctly skilled. So if I could get you to do those two things, I would really appreciate that. So with that, I'm going to open it up for more questions, and feel free to post them in the chat or the Q&A window.
Jesse, while we're waiting for some questions to come in, do you want to actually drop those links in the chat?
Sure. So I also apologize that I wasn't able to share my screen right. To have this chat up with Zoom, you can't do full screen. It's super annoying. So I apologize on that.
Not a problem. It's a small corner of the screen, so.
Oh, it's actually entirely black on there, or gray or something?
It's just, yeah, it's just a corner.
Oh, I thought they masked that out. That's
yeah,
that's so annoying.
I know. I feel like it's an update from Zoom.
So I guess what I could do is talk more about what's in the book. In the book that I obviously share what the data teams are, but I go even deeper than that. Oftentimes when people are trying to create their data teams or start with big data or whatever, they don't understand the team itself. So I go through what the team is, the skills for the team, and the roles on the team. And this is incredibly important as you're starting out because it's not well known. So the subtitle of the book is called a unified model for doing data focused projects. And this unified model is important because it brings all three of what you need together. And this is what you need to be successful. You need all three teams to be successful. Usually when you read a data science book or machine learning or AI book, they're solely focused on the data science side. And the data science side is interesting. It's the cherry on top. It's the last mile of what we're trying to do. But they completely leave out the data engineering foundation that needs to be there for all of this to be successful. And oftentimes when we talk to those teams or talk to the people who are the case study, they say, oh yeah, there was data engineers there, but they're not mentioned. And so in this book, I'm trying to put all three teams front and center, saying, yes, you need data engineers. Yes, you need data scientists. Yes, you need operations. No, you probably won't be able to find a data scientist that can do it all. And they do exist sometimes, but by and large, it's several different teams, several different people all brought together.
Yeah, absolutely. I have a question on that. I hear a lot about data scientists and understand that role as well as data engineers. I think this idea of operations on the data team is a bit newer. What type of background should managers be looking for that type of role?
For the operations role?
Yes.
For the operations role, it can be a wide array. In fact, I'm in support of the book. I'm doing a video on interviews and what and skills that should be there for operations. So what operations I say is an operations engineer is somebody who's taken their operational background and applied it to the sorts of frameworks that we're using. For example, if you're looking at Pulsar, you would want to make sure that your operations person has a background in Pulsar. And you're also wanting to make sure that they not just have, say, on paper, I understand theoretically Pulsar. You'd want to be able to say, and I have supported Pulsar at this scale. That's another key issue there. Another possibility is that some companies expect their operations team to have some level of scripting, perhaps even some rudimentary programming. You want to communicate that as well. But by and large, it's saying, here are the frameworks that we want you to support, and depending on how big the operations team is, if they're short on they have two of the three frameworks that you need, maybe they can pick up that third, maybe they can go to a class on that third one. But if they're the only one, more than likely they'll have to go through all three. So one expansion to this question is around, well, how does cloud change this? As we all know, clouds are becoming more popular. So we have Pulsar Cloud, or I think you called it Pulsar Cloud, or StreamNative Cloud. I can't remember what you called it.
Oh, StreamNative Cloud launched last week.
Cloud, thank you.
Yes.
So congrats on that. So we have StreamNative Cloud. So how does StreamNative Cloud affect operations team? And I kind of go through that. So one common issue is that managers think that we don't need any more operations people because we're using cloud. What we do need is we don't need as many people, but we still need some operations people there. What I love about the clouds is that it reduces the operational overhead to get to that point. So we were talking before just a second ago about what happens to get us. What happens if we have a person that doesn't have two or three or have the knowledge of that framework? What we can do is we can roll that framework out without having to have all of the operational knowledge for it. and our team, because there's, in the case of StreamNative Cloud, StreamNative is handling the Pulsar operations. Your operations person is handling some of the operations on top of that, but they don't have to become Pulsar experts. So what this allows the team to do, the data engineering team, is to look at technologies without having to really think about, this is going to be an operational pain because we have to do the ops for this. And we can't, and as we calculate out, I'm going to roll out Pulsar, we don't have to think about, oh my God, it's going to take forever for us to learn Pulsar. Now we just say, okay, data engineering team, you need to learn the architecture and how to program with Pulsar, and our operational overhead is significantly lower there. So Michele has a question there. What about the data teams embedded to P&T cross-functional teams? Does the book talk about the pros and cons, how to manage this kind of collaboration? I actually do, yes. It's because at an organization large enough, what will often happen is you'll have your data engineering team, you'll centralize, but you'll eventually have needs from the other teams without. So what you really want to do is to have teams that are embedded within each one of them eventually. So you may have a center of excellence, a core team, but you may have data engineers go out to those business units. So what's important there is sometimes the inverse happens, that the business units start hiring. And when we have business units hiring technical people, what often happens is that they don't hire the right people. So what we need to do is we need to make sure that our data engineering team is part of that discussion, part of that, how do we find that data engineer for you? Perhaps another thing I talk about in the book is a rotation, that we may have people rotate out from our centralized data engineering team into that business unit for some amount of time and rotate back in. The reason we may want that rotation is maybe that data engineer doesn't want to stay in that business unit, and it's just a necessary thing. Some pros and cons there is that if we do that rotation, that means that if we're in a high domain knowledge issue, that domain knowledge is lost each time. That may be difficult. So what we may want is, in high domain issues, that we're centralizing that person with the business unit with a good high bandwidth connection between those two data engineers. If you have a follow-up question there, Michele, just go ahead and chat it out. So Marco, hi Marco, hopefully you're doing well. What are the tools and knowledge in order to do real-time processing nowadays in a data engineering profile? I think that with real-time, we have an even larger amount of technologies out there with even more importance of understanding the trade-offs there. That means that as we start to do data engineering in real time, let's say Pulsar. Pulsar is a great way for moving that data around. We can use Pulsar SQL, for example, to process that. But what are the pros and cons? Just hearing SQL, we think, okay, well, we can do this and that with SQL. Hey, that may be great. That may be the wrong thing. We may actually need this technology and that technology. One of the issues as we start to do in real time is we're going to have to move data in real time so that the technology is able to keep up with that data in real time and query in real time. And that's a whole issue unto itself. Is if we're, let's say, powering a real-time dashboard or powering something like this, something in real time, we need to make sure that the entire architecture all the way through supports that and supports those latencies, for example, and supports this and supports the SLAs that we want. So it's going to be really important that we do that. I also think it's important to understand the trade-offs of each at a large depth, because Pulsar is great for this, but is Pulsar great for this? What level of processing do we do with Pulsar? For example, if we're going to do, let's say, some kind of complex event processing, CEP, is Pulsar the right technology? Maybe Flink is. This is really core, this is really key that the data engineers on the team know this. Because if you're just either designing by case study, designing by what's most popular, you may think, oh, Spark streaming, that's most popular, Spark, because Spark is popular. But is Spark Streaming popular? Not really. What we need to do is the data engineers need to be looking at the right tool for the job. And this is really what makes data engineering difficult, is it's having a knowledge of lots of different technologies, 10 to 30 different technologies in play to be able to make this choice right. Okay, Jared asks, how does this fall into an organization practicing Agile where you have cross-functional teams? Would each team ideally have their own data engineer, data scientist, and operations resource, or do you see it as a big data engineering team that sits outside of product teams? Actually, I'd like to expand on that because I actually go through that in the book as well. Because you're talking about Agile there. So one in the book, a great deal of my book is a body of work that doesn't exist anywhere. And something I'm very proud of in there is the case studies and interviews that I do. And in those case studies, I actually ask them, are you using Agile for data engineering? Are you using Agile for data scientists? Because Agile may or may not be the best practice for data scientists. So you saw the organizational design I talked about initially. Of this is what we initially need to do. We may have separate teams, but I also start to talk about the most advanced organization of teams, and that is around data ops. And I talk about that in the chapter, where in order to remove the friction of resources, so even with separate teams, you're still going to have resource restrictions and resource friction, because you'll have to coordinate with this manager to get some resource. But if we start doing data ops, and my definition of data ops is a team that can do a beginning to end value creation of a data product. And that beginning to end is the data engineering, the data science, the operations, the product, the front end if there's needed, the whole thing, the whole way through. And this way we don't have friction around that, but it's a more advanced style. And there are even some interviews I do in the book that actually talk about what this looks like long-term and the value created. So that's Harbinder's interview, and that's another interview with Bas Jerding from ING, and Harbinder is from Money Supermarket. Okay. So it looks like went through the questions. Those are the other ones. I'll give a few minutes or a few moments to ask any more questions there. Or Carolyn, do you have another question?
I actually do. You're, I think, kind of just touching on it, and this is really based on Jared's question, but we hear a lot of talk around organizing teams in pods. So how do you think about this in from a data engineering perspective?
In the pods, if you're talking about the Spotify pods model, that's kind of that data engineering model, or excuse me, data ops model that I talk about in the book. Just as an aside, if you're familiar with data ops, my definition is slightly different than the various other definitions out there. Sometimes the definition of data ops is more of a DBA 2.0 or data warehouse 2.0, something like that. But this pods model is Spotify popularized a model where instead of having teams in chunks, what we have are guilds. Those are now guilds, and then we have them in pods when we actually go to put them in teams, so that we have cross functionality. Mm-hmm. And as I did the research for the book and I talked to the people, I definitely think that is the highest and best usage of our teams, but it's an advanced configuration. What I want to be very clear on is I don't think that you should go to data ops unless you have mastered the foundations. Because once you spread everybody to the wind, unless they have good foundations, unless they're doing things right, once you spread them out, that knowledge is going to be difficult to transmit around. So teams, companies that are doing data ops, that are doing pods like that, they'll have weekly, maybe monthly meetups of the entire guild. But the issue there is that that's monthly or it's weekly. It's not daily. It's not hourly, as it were. So what we really want to do is make sure that we have good, strong data engineering foundations, that we have the right data engineers, that we have the right data scientists, that we have the right operations people. And then once we're, the metric I look for is that the biggest issue for us is now friction. It's cross-team friction. It is not beginning friction. It is not technical friction. It is not getting things into production friction. Our entire friction is based around the cross-team friction. Does that make sense?
Yeah, absolutely.
Excellent. Okay, Michele asks, in some manner, the analytics tools are also real-time solutions. In your experience, how do you see the duopoly between analytics tools and custom ETL BI within the same company? The risk is to have a double source of truth. Yes, that is a definite issue with a double source of truth. So what we're trying to do with the right technology, with the right architecture for this, is that we will have a single source of ETL that is put into multiple systems. So if you have attended my, for example, I teach Pulsar, I teach Kafka as well. When I teach those classes, we go through this S architecture. And what an S architecture means is that we are only doing certain things once. We are only ETLing once. We are getting into a binary format once. So that when we do our consumption at these analytics tools, at this custom ETL, this custom BI, that at that point, we're all pulling from that same source of data. Now, you may still have issues around eventual consistency and that sort of thing relative to the system we're putting into. But what we should have is that let's say it's money. So we've sent out some kind of money. In the first step, we have taken that money from, let's say, a string, and we are now putting that money into 2 integers. So there isn't going to be an issue downstream of this analytics tool, this custom BI system down here is taking that money and doing something with it. It's all been created into our money, big decimal, whatever, up here. And that as we consume that all later, now we have our analytics tools consuming the same data. It's going to be stored differently, stored in a different system perhaps, but we'll at least be able to have done all of our ETL, all of our sanity checks up here. By having all of our sanity checks up here, if we need to throw out bad data, for example, we don't have to do it down here at these analytics systems. We've done it up here at the very top. So this is out of that. What we also want to do or deal with is, of those systems, what is the source of truth? Now there may be several sources of truth. What we may say is, in the event that these 2 systems differ, here is the one that we're going to trust and say is correct. And the one we say is correct is maybe one with higher ACID transactions. Or we may go back to the actual files and say, let's run a Spark job over the files laid down into HDFS or S3, and we'll do the calculation that way. Hopefully that makes a bit of sense, Michele.
Okay, great. Well, yes, she responded, thank you. As we wrap up, we have a couple minutes left. So if anyone wants to add a question in the chat, please do so. I'll also just add right now a link to sign up for the Pulsar newsletter. This is a great opportunity to stay up to date with what's happening in the Pulsar community and to get news on more great events like this webinar with Jesse Anderson. So if you want to be in the know about Pulsar events, great opportunities like this with industry experts, and you're not yet signed up, please click on the link and sign up now. Looking forward to more great events like this. You want to give them a minute, Jesse, and then we can
go try out StreamNative Cloud as well.
Absolutely. Eugenio, I just posted it. Do you see?
You only send it to all panelists, Carolyn.
Oh, all right. There we go. Thank you. There we go.
Oh, the many annoyances of Zoom.
I know, so many nuances, changing all the time. A great tool overall, but definitely not without its challenges. So I just went ahead and shared it with all of the attendees, not just with Jesse, who has already signed up for the email list. Yeah, and as Jesse mentioned, we launched StreamNative Cloud last week. The beta is open right now. We have some people up and running, so very excited about that. And as Jesse mentioned, great opportunity. If you don't have the ops expertise in Pulsar, we can definitely help you with that and streamline your adoption of Pulsar and help your team get moving pretty quickly.
Yeah, all the things I'm excited about is that whenever you're trying to do that calculus for deploying the new technology, having these clouds just makes it so much easier. It's okay. We want to use Pulsar and we want to use Imply. Okay, we've got StreamNative Cloud and we've got Imply Cloud. There we go. And since they're all on the same cloud premises, we can keep them all together. We can process that data. Oh my goodness, so much easier.
Yeah, absolutely. Awesome. Well, it looks like we are just about on time. So Jesse, want to thank you again. Amazing presentation. Lots of positive feedback in the chat. So thank you all of our attendees for participating and for being a very engaged audience. Obviously a really hot topic right now. So we'll definitely keep an eye out for your book and very interested to read that.
All right. Thank you, everyone. And thank you, Carolyn. Have a great
All right.
rest of your day.
Thank you guys. Bye.